Okay, so let's look at our example 3. So you have a motor that is turning a wheel. If the pulley A here is connected, which is connected to the motor, begins to rotate from rest with a constant angular acceleration. So you have constant angular acceleration here, meaning you can use your 3 formulas of 2 radian per second square. Determine the magnitude of velocity and acceleration of point P of the wheel. So you need to find the connection between the angular acceleration and the actual acceleration at point P. After the pulley has turned 2 revolutions, meaning you have your angular displacement here. You can assume that there is no slipping. Okay, so you need to summarize what you have known. You know your angular acceleration 2 rad per second square, and also you know your displacement is 2 revolution. 2 revolution, how many radian? You know 1 revolution is 2 pi, right? So meaning your displacement is 4 pi, and as you know, pi is 3.142, right? So you can calculate if you want directly and get the values, which should be 12.57 radian. Okay, so you have this. You know the acceleration is constant, so you can use your formulas. So what do you need? You need your velocity. So because you also know your formula, to find the magnitude of velocity, you need to multiply your angular velocity with your radius, right? And also you also know that the tangential acceleration you can find by multiplying the angular acceleration times the radius, and the normal acceleration, if you're interested in the magnitude, is equal to angular velocity to the power of 2 times the radius. And to find the value of acceleration, you need to find the square root of at to the power of 2 plus an to the power of 2. So what do you need? You know your angular acceleration, right? So what is left is for you to find the angular velocity. So you know your displacement, you know acceleration. How do you find the angular velocity? You can use your formula. Angular velocity power of 2. Initial angular velocity, if it starts from rest, it's 0. 2 times not A, it is alpha, is alpha, so constant acceleration, times the displacement minus initial displacement, which is 0 lah in this case. So getting out your information, 2 times 2 times 12.57, which, if you find the angular acceleration, you should get 7.090. Don't forget, you need to find the square root lah after you calculated this. So find the square root, you should get 7.090. However, before we continue, there is one thing that you need to notice, is that there is a difference in the radius between your input and output, right? So what this means is that you need to know the velocity, the tangential velocity, and the acceleration should be the same for the input and output, because this is connected using one cable, right? So the V here should be the V here, and the acceleration here should be the acceleration here. However, the angular acceleration and velocity will not be the same. So you know v is equal to the angular velocity times the radius, right? So the v here should be equal to v here, even though the r and the omega is not the same. So what you can do, so let's say this is pulley A and this is pulley B, right? So VA is equal to VB, which is omega A, RA is equal to omega B, RB. And what you have calculated just now here, is it for A or is it for B? So here your acceleration is actually for A. So this is actually omega A. So knowing omega A and its radius, and you also know the radius of RB, can you find the omega B? Yes, right. So calculating for omega B, which is equal 7.090 times 0.15, the radius for A, divided by the radius for B, which is 0.4. You should be getting 2.659 radian per second. Similarly, for acceleration at A should be equal to acceleration at B. And how do you find? I'm sorry, this acceleration in this case is tangential lah. And velocity, of course, is tangential lah. You don't need to write tangential, but this is for tangential acceleration. So, what is the formula for tangential acceleration? The angular acceleration times the radius. So, similarly, angular acceleration for A times RA is equal to angular acceleration B times RB, which is 2 for angular acceleration A is 2, radius 0.5 is equal to angular acceleration B times the radius 0.4. So calculating for B, acceleration B, angular acceleration B, you should get 0.750 radian per second. Okay, so now you need to find what is the value of the acceleration. Okay, so summarizing what we have calculated, we know that the angular velocity for pulley B is 2.659 radian per second, and the angular acceleration for pulley B is 0.750 radian per second. And what is the velocity? What is the tangential acceleration? What is the normal acceleration? So you can find the value of A. So based on our formula, we know that V or Vd, well, velocity is always tangential, V is equal to Wb times the radius. So we already know 2.659 times the radius is 0.4. You should get 1.06 meter per second. Well, what about At? At is acceleration at B times the radius. So acceleration is 0.750 times the radius 0.4. you should get 0.3 meter per second square. And you want to find out the magnitude, it is omega b to the power of 2 r, radius of b. So it is 2.659 to the power of 2 times 0.4, which you should get 2.827 meter per second square. So finding a is equal to finding the square root of 80 to the power of 2 plus an to the power of 2. So 0.3 to the power of 2 plus 2.827 to the power of 2, which, solving for it, you should get 2.84 meter per second square.